Good evening, our students, and welcome to this evening's class. Today, we'll be continuing to look at matrix and matrix operations. If you remember some of our previous classes, you will recall that we already had gone far looking at operations in matrix as it concerns addition of matrix, subtraction of matrices, and even multiplication of what of matrices. Today we want to continue to look at what we call determinant of a matrix. Determinant of a matrix. Determinant of matrix. Of matrix. We are going to look at these concepts under two categories. One, determinant of a 2 by 2 matrix, and then determinant of a 3 by 3 matrix. But for now, we will be looking and discussing in details, including taking questions on determinant of a 2 by 2 matrix. So we are looking categorically at determinant of a 2 by 2 matrix. Determinant of a 2 by 2, yes. Let me write it this way, 2 by 2 matrix. What we mean by 2 by 2 here is that the matrix is made up of 2 rows and 2 columns. That's what we mean by 2 by 2 matrix. Of course, it is a square matrix. Square in the sense that the number of rows and the number of columns are equal. So if you are asked to write a 2 by 2 matrix, you can decide to write it using any notation of your choice. For instance, if we are paying attention to a matrix defined by a capital letter A, then we have that a 2 by 2 matrix, a matrix what A, where this two matrix A is a 2 by 2 matrix, is defined as you have this, you have A11, A12, A21, and A22. This is what you have. So by implication here, there are 2 rows, that is 1, 2. 2 rows, and there are 2 columns. 1, 2. 2 columns as well. When you are asked to find the determinant of this words matrix A, it is either written in these 2 ways. You can either talk about what? Determinant of what? A, written as what? Det A. You can write it as what? As det A. And this det A is defined as the product of the leading diagonal. This is what we call the leading diagonal. The product of the leading diagonal entries minus the product of the minor diagonal entries. So this arrow here is talking about the leading diagonal. This arrow here that goes this way is talking about minor diagonals. So the entries of the major diagonals are A11 and A12. So if you talk about the product of A11 and A12, you have A11 multiplied by what? A22. You close it, minus. You talk about the product of the minor diagonals, or the product of the entries of the minor diagonals. So you open a bracket. The entries of the minor diagonals are A21 and A12. So you have A21 multiplied by what? A12. You close up the brackets. Do remember that multiplication is commutative such that this expression can be written this way without anything being changed. This one can come over here where I have A22 multiplied by A11. Close the bracket, minus. This one can come first, A12 multiplied by what? A21. Both of them will give the same answer, exactly the same answer. Now, this det A can equally be written that way. It can equally be written this way. This thing means determinant of what? Of a matrix what? A. What appears like absolute value. Okay? So this equally means that A, this equally means what? That what? A. Determinant of A, determinant of A. So by implication, this one is equally defined as what? A what? 2, 2 multiplied by what? A1 what? 1 minus. You open a bracket, A1, 2 multiplied by what? A2, 1. They mean the same thing. So anytime you are asked to find the determinant of a 2 by 2 matrix, um, without them necessarily telling you how the matrix should be defined, you make a definition of your own choice. It can be a matrix A, it can be a matrix B, or any kind of matrix. Then this is how to report its determinant. So we are going to take few questions from this and see how we can solve a problem with this. Always remember this formula: product of the entries of a major diagonal minus the product of the entries of a minor diagonal. Same thing applies here, same thing applies here, down here, and down here. So permit me to clean the board while we just take few questions now under it now and see how they ask us the questions in those kind of problems. We are discussing 2 by 2 first. I have a question which I'm going to read out, and that question says, and I write. The question says, and I write. It says, number 1. It says, obtain the determinants of this matrix A equals, I have 2, I have 6, I have minus 1, and I have what? 4. That is just the question. That we should obtain the determinant of this matrix A defined with these entries. The good news here is that this determinant A, or this matrix A, contains 2 rows and 2 columns. 1, 2 as rows, 1, 2 as columns. So we are going to discuss it now under the determinant of a 2 by 2 matrix. So as a way of solution, I'll write this way: solution as a way of solution. Do remember that the determinant of A can either be written as this, what looks like absolute value of what? A, or you can write it to be what? Det A, and that det A is defined as the product of the entries of the major diagonal minus the product of the entries of the minor diagonal. The major diagonal runs from 2 down to what? To 4. So I have, open a bracket, I have 2 multiplied by 4, close bracket, minus the product of the minor diagonal, the entries of the minor diagonals, which of course is, open a bracket, here is minus 1 multiplied by what? 6. I will close the bracket. So we now say 2 times 4 will quickly give me what? 8. Okay? The sign here is what? Minus. Minus 1 times 6 will give me what? Minus what? 6. And do remember that in mathematics, minus minus means what? Plus. So what you have here becomes what? 8 plus 6, which gives us what? 14. So the determinant of this matrix is what? Is 14. It just simply you saying the product of the major diagonal, entries of the major diagonal, minus the product of the entries of the minor diagonals. And with that, you have arrived at your answer. Okay? So let us quickly look at another problem. I know that this is just the beginning of likely questions that you might see under determinant of a 2 by 2 matrix. But I assure you, we are going to call up some questions that's actually going to give you enough idea on how to navigate your ways around questions surrounding this 2 by 2 determinant of 2 by 2 matrix. Okay. Let us equally see another question which they gave us. Look at how this question is. That is question number 2. Question number 2 says if D equals, here is 7, here is 2, here is minus 3, and here is 6. They say we should find D raised to power 1 over 2. That's what they asked us to do. And do remember very much well that this your A given this way is already talking about what? Determinant of what? Of D. Because you are already seeing what looks like an absolute value covering the what? The matrix. If it were not determinant, this could have been written this way. It could have been written this way. But because they are already talking about determinant, they left it now to appear as if it were referring to absolute value. So what we are going to do quickly is to tell ourselves that our D as a way of solution, we tell ourselves that our D is given as product of the entries of the major diagonal, which is talking about what? 7 times what? 6 minus. You open a bracket. We talk about product of the minor what? Diagonal, which of course we are talking about minus what? 3 times what? 2. We close up what? The brackets. So what we have here is, so we now, this thing boils down to what we call 7 times what? 6. The sign here is what? Minus. And then we have here minus 3 times 2, which will definitely give us what? Minus what? 6. And like we have always said, that minus minus in mathematics means plus. So this is as well written as 7 times 6 plus 6. Surely if you pick up your calculator and you say 7 times 6 plus 6, the answer will definitely give you 40 what? 8. However, we were not asked to find D, we were asked to find D raised to power 2. And in mathematics, D raised to power 2 is just like talking about square root of D. So any day they talk about D raised to power 1 over 2, it is the same thing like talking about square root of what? Of D. Talking about square root of D. And good enough, we have found that our D is what? Is 48. So this thing implies that we are talking about square root of what? Of 8. And of course, 8 is not a perfect number. It doesn't have what? A square root. So on that note, we are going to find a way we can break this 48 now into what? Into 2. Such that one of the numbers now becomes what we call a perfect number. And by doing that way, of course, if you pick up your calculator and check, you'll find out that the 8 is the same thing as 16 times 3. You can press your calculator to see whether that is correct. So if 48 is 16 times 3, and what we have here is square root of 48, we now say therefore, our D raised to power 1 over 2 is given as square root of what? 16 times what? 3. And by way of a sword, whenever we have square root of the product of two numbers, it can be split into 2 to have something like square root of what? Of 16 multiplied by square root of what? Of 3. And square root of 16 is what? 4 multiplied by root what? 3. And this becomes 4 root what? 3. So while D is 48. D raised to power 2, which they ask us to find, is 4 root what? 3. So we should have to pay attention on how to go about that. I don't want to believe that this is a challenge for now. So let us still equally clean the board and take up another question that can be challenging. Okay, we have another question that is written this way. We call that one question number 3. That question number 3 says, if the determinant of Q is given as, here is x plus 4, here is x plus 1, here is x minus 1. Is given as what? 2, that we should find x. We should find x. Find x. That's what the question is talking about. Okay? Permit me to bring my curtain down because of the reflection of light. I think it's better. It's a little better compared to how it was before. So the question here is saying that the determinant of a matrix Q, which is defined with these entries x plus 4, x plus 1, x minus 1, that the answer is 2. We should find the value of x. It's not going to be a difficult one, in the sense that we already know that this matrix which we have here is a 2 by 2 matrix. And then for us to find the determinant of a 2 by 2 matrix, we talk about the product of the leading diagonals minus the product of the minor diagonals. And then of course what we are now going to have is that this determinant which we have here, is the product of this one is this way. So what we are going to have here is going to be x plus 4 multiplying x minus 1 minus the product of the minor diagonal, which is this going into this, which is the same thing as this x going into this. So I can just write x into x plus what? 1. We are told that the answer is what? 2. So what we are going to do is to try and open this bracket. And by way of opening this bracket, what we have is this. X times this x raised to power 2. X times minus 1 minus what? X. The sign here is what? Plus. 4 times x will give me 4x. The sign here is plus and the sign here is minus. Plus times minus will give me minus. 4 times 1 will give me 4. Minus. X times x is what? X raised to power 2. Here is minus. When this minus comes in here, it will affect this plus to become what? Minus. X times 1 will give me what? X. We are told that this is equals what? 2. So we try and collect like terms. By way of collecting like terms, here I have x raised to power 2. Here it's just like you are owing x, but you have got 4x. That is what is meant by minus x plus 4x. You are owing 1x and you have got 4x. So if you pay up that 1x, you have 3 left. So you have plus what? 3 what? X. Minus this what? 4. Then you have minus x raised to power 2 minus this what? X is equals what? 2. Another thing you need to understand here is I have x raised to power 2 here, I have minus x raised to power 2 here. So they can cancel out of the equation. So this and this is gone out of what? Of the equation. Here I have what? 3x. But I'm equally owing somebody x here. So once I pay up now, what I have now reduces by 1. So what I now have here becomes 2 what? X. Here is my minus what? 4 is equals what? 2. Now this my 4 and this my 2, I like them, so they should be collected together. So this 4 going over there, we have that 2x is given as what? 2 plus what? 4. And 2 plus 4 will give me what? 6. So that I have 2 what? X is equals what? 6. Trying to make x to stand alone, I divide both sides of the equation with the coefficient of what? Of x. So this is all over 2, this is all over 2. These 2 will cancel these 2 here, and I'm left with x. 2 here is 1, and 2 into 6 is what? 3. So actually, the value of x is what? Is 3. For this system of equation to be 2. Such that if you plug in 3 here, you say 3 to this to give you 7, plug in 3 remains here. Here is going to be 4. Here is going to be 2. So I say you can say check 7 times 2 minus this 4 times 3 to know whether actually you are going to have the determinant of 2. So that's how to go about that. So sorry, there's a reflection coming out from my through my window, which I want to believe is affecting the clarity of this video. I'm so sorry about that. Very soon, I think that rays of light will go off. So permit me to clean here while we take up another question. Okay, the question we are going to take is equally simple. Simple in the sense that we already know what we are doing. I call that question number 4. That 4 says if -8 -4 y equals, here is 3, here is 5, here is 7, here is what? 9, here is 9, and here is 7. We just show ourselves what we are going to do, and I ask you to complete the solving as a way of testing your understanding thus far in the class. Here is already determinant, here is already determinant, okay? So what we need to do is to evaluate the determinant here and equate it to the determinant of this one. So what we are going to have is -8 times y, minus what? 8 times what? Y, minus. This one will go over here. Let me be putting them in a bracket so it won't confuse us, okay? So we now open a bracket again. So -4 times 4, we have minus what? 4 times 4. Close up the bracket. We are told that this is equals. We open a bracket, 3 times 7, 3 times 7, close it and minus. We open a bracket, 5 times 9. So we have 5 times 9. We close the brackets. So -8 times y will give me -8y. Here is my minus. -4 times 4 will give me minus what? 16. This equals 3 by 7 will give me 21 minus 5 by 9 will give me 45. So what is going to happen here is I have -80y, minus will give me plus 16. This is given as so this is going to give me 24. It's going to give me 24. So which is -24 indeed. It's -24. That is 21 minus 45. So that what you are going to have here becomes -8y equals -20 what? 4. This one coming over here -16. So you are owing 24 and you are owing 16. So our -8y is going to be given us as a -40, I guess. That is 24 plus 16. So you can talk about dividing both sides with -8. So I have here to be -8, I have here to be -8. So at this -8 will cancel this -8y. This minus will cancel this minus. 2 here is 4, 2 here is what? 20. 2 here is 2, 2 here is what? Is 10. Then 2 here is what? 1, and 2 here is what? 5. So I guess y is equals to 5. So you need to cross check it to know whether actually what we did there is right. The most important thing that we just wanted to carry you through the methodology of solving that kind of problem. Thanks very much for your audience. Let us go over to the next class to manage the size of this video and talk about a determinant of a 3 by 3 matrix. Thank you very much for your audience. And do remember to share, like, and comment, and equally subscribe to our YouTube channel, Mathematics and Statistics Masterclass.